hit the x-axis? At -2. If it hits at -2, what would my factor be? X plus 2. Now, at -2 it bounced, so that means you need a square. The next place it hits is 3, so we need an x minus 3. I said find a cubic that's degree 3. Is this currently degree 3?
Yes.
Yeah, so I've got my zeros. But there's one other thing I need. What? We could have a number out in front. So if you look at your graph, it hits the y-axis at -3. That means the point 0, -3 is on this graph. So what we're going to do is plug this in and solve for that coefficient. So if I put in a 0 for all of my x's, this thing has to equal a -3. So 0 plus 2 is 2, squared is 4. So I get a -12a equals -3. And my a is 1/4. So your polynomial is 1/4 times x plus 2 squared x minus 3. So I want to talk about that one just to remind you that you do need to find that coefficient using your intercept on the graph. So you'll probably have one of those on your test. Any questions on that one? Number 10, are you guys okay with the maximums, minimums, those questions? No? Okay, let's look at it. Okay, minimum possible degree. Now, if you're looking at this one, it only has 2 x-intercepts, but we've talked about the degree is 1 more than the number of turning points. This graph has 3 turning points, so what would my degree be? 4. B, local min. So you're looking for a point that is lower than those surrounding it. What would that be? This one right here, MN. C, local max. So a point that's higher than those surrounding it. Right, there's 2 of them. This is a local max, and this one's a local max. Absolute min. Is there an actual lowest point on this entire graph?
Unless it goes down forever.
Right, it keeps going down forever, so there is none. E, absolute max, a highest point on the entire graph.
AB.
AB. F, domain. So that's talking about my x's, going from left to right. As this graph keeps going down, it's going to get wider and wider. It's extending in both directions. So what's our domain? G is the range, talking about your y's, going from the bottom up. So if this is going down forever, it's coming from -infinity. And the highest it hits is right here, which has a y value of b. Is that one all right? Okay, so problem number 9. I'm probably going to give you one like this on the test, where I give you the first 0 and ask you to find the remaining ones. What do you do if I give you that first 0? Synthetic division. I'm not going to do this one right now. If I have time at the end, I can come back to it. But you would just start with synthetic division with the first one I gave you. On both of these, I gave you an imaginary one. So what else has to be a 0?
The conjugate.
The conjugate. So you'll end up doing synthetic twice. Once with the one I gave you and once with the conjugate. Okay. Do I need to work through that, or you guys know what that means? Problems 8 and 6 are really the same. So out of those four, 6AB and 8AB, I will work one of them. Do you guys have any preference on which one? Let's look at 8B together. So I am telling you your polynomial. If I want you to find the zeros of this, if you just graph it and write down the numbers from your calculator, you're going to miss a lot of points. What do I expect you to do here? P's and Q's. So the P's come from where? Constant. Everything that goes into 18, and you have to put a plus and minus on each of those. So we could do 1 and 18, 2 and 9, 3 and 6. The Q's come from leading coefficient. So this is a 1x to the 4th, so it's just plus and minus 1. So the possible zeros are P over Q. Okay, so you do 1 over 1, 18 over 1, 2 over 1, so forth. In this case, we're just getting all of our P values again, aren't we? Does everybody know how to get this list? Then what do we do? Exactly. We have to find one that is a true zero. So you can use your graph to narrow it down. Graph this and look at where it crosses the x-axis so we know its starting point. So what's one that works? -3, okay. So I'm going to do synthetic with -3. So 1 comes down, multiply. Okay, now I have an x cubed plus a 3x squared plus 2x plus 6. Ideally, we get this to the point where we can do like Box method or quadratic formula. It's still an x cubed, so what could I do? Pick another 0. So looking at the graph, where is another place that it hits? What happens at -3 on this graph? What does the graph do? It bounces, which means -3 works twice. So I'm going to do synthetic again with the -3. And the answer I just got out. So my remainder, constant x and x squared. Okay, so at this point, it's now a quadratic, so we could do quadratic formula. Really, I'm just trying to figure out what makes this equal to 0, so couldn't we solve that? Do you subtract over your 2? How do you get rid of a square? If you had a square root, you need?
Plus or minus.
So x equals plus and minus, we'd have to take out an I radical 2. So I asked you for two things here, the zeros and the factored form. The zeros would be the plus and minus I radical 2. It was a degree 4, so I should have 4 of them total. That's 2, I radical 2 and negative I radical 2. What else worked?
X plus 3.
So my 0 would be a -3, and it worked twice, so we put multiplicity 2. Zeros are just the numbers. The factored form is when you put the x with it. So if I radical 2 worked, your factor would be x minus I radical 2. If it's negative I radical 2, you'd have x plus I radical 2. Since it's negative 3, we have x plus 3. Since it was multiplicity 2, it gets a squared. Like I said, problem 6 is the same as this. You're just not getting any imaginaries in that one. So after you do your synthetic, you usually end up with a quadratic that you can factor using box method. Are we okay with that? That type of question is probably worth like 10 to 12 points on the test. So make sure you know how to do those. It's a lot of points. Let's see. Is there anything else? I've got a few more minutes. If I need to work out another problem, I can. Is there anything else you want? Yes.
Number 5 and last zeros is just a 9, right?
It would be 8. Maximum number of zeros is the same as your degree.
What was?
You're thinking turning points. Your degree is one more than your turning points.
Okay.
Can you do 9b because I'm getting the wrong thing.
Okay.
My remainder is definitely not 0.
Alright, so 9b is a pretty ugly one. I gave you the first 0. If I give you the first 0, what do you have to do? Synthetic. So we're going to do synthetic with 3 minus 2i. If 3 minus 2i works, what else has to work? So I'm going to do synthetic once with 3 minus 2i and then the second time with 3 plus 2i. Alright, so this one turns out a little bit uglier because the 0 has 2 terms in it. But it's the same process. 1 comes down. 1 times 3 minus 2i is 3 minus 2i. If we add like terms, negative 9 plus 3 is negative 6 minus 2i. So now we have to multiply. We have 3 minus 2i times negative 6 minus 2i. So if you FOIL, you get negative 18 minus 6i plus 12i plus 4i squared. 4i squared is the same as plus negative 18, and then negative 6i and positive 12i is 6i. So if I add like terms here, 21 and negative 22 gives me a negative 1 plus 6i. So I need 3 minus 2i and negative 1 plus 6i. So if I FOIL, negative 3 plus 18i plus 2i minus 12i squared. Negative 12i squared is 12 plus negative 3 is a 9. 18i and 2i is 20i. If I add 21 plus 9 gives me a 30 plus 20i. We have to FOIL one more time. 3 minus 2i and 30 plus 20i. So 3 times 30 gives me a 90 plus 60i minus 60i minus 40i squared. Negative 40i squared is 40 plus 90 is 130. Positive 60i and negative 60i cancel, so we get a 0. We know that has to be 0 because I told you this was a 0 of the polynomial. So if you get anything else, go back and find your mistake. The second synthetic is always going to be pretty because all these i's are going to disappear. So I use these coefficients. So 1 comes down. 1 times 3 plus 2i is 3 plus 2i. When I add those, the 2i's drop and we get negative 3. So I need to do negative 3 times 3 plus 2i. You distribute, you get a negative 9 minus 6i. When we add those, what happens? I's drop and we have negative 10. So now we need negative 10 times 3 plus 2i. So that's negative 30 minus 20i. So my 30's drop, my 20i's drop, and we get 0. It's my remainder, constant x and x squared. Now what can I do with this? Box method. X squared breaks into x and x. What multiplies to negative 10 and adds to negative 3? So our question was to give the remaining zeros. So I gave you 3 minus 2i. You don't have to list it again. The others were the 3 plus 2i. What makes x minus 5 0? Positive 5. What makes x plus 2 0? Negative 2. And that's our final answer. Only other thing that I definitely want to mention on this study guide, on 2b, if I want you to find the zeros of that, what do you have to do first? Take out an x squared. It has to be in factored form to get the zeros. So on that one, you can factor it yourself, take out an x squared. Alright. Otherwise, test is tomorrow. I will collect the study guides then, so please work through that. If you need any help, come in during advisory, shoot me an email, come in the morning, whatever we need to do so I can get your questions. What? Right, if it's a polynomial. You're welcome.